The main goal of this tutorial is to provide a good understanding to the non-chemist of the various raw materials used within UV, EB formulations, their functionalities, and their advantages and disadvantages within a wide range of formulations. This tutorial is divided into two major sections. Section 1 will focus on the raw materials used in UV chemistry for coatings, inks, and adhesives in free radical, cationic, and hybrid polymerization. Section 2 will concentrate on how to select the proper raw materials for specific applications. Also reviewed within this section will be a broad range of starting formulations for various applications, such as wood, metal, plastics, and inks. The overall properties of any coating, ink, or adhesive to be cross-linked by radiant energy are determined primarily by the oligomer used in the formulation. Oligomers are moderately low molecular weight polymers, which have been specifically designed to impart a desired set of properties. Oligomers vary in molecular weight from around 400 to 7,000. While the lower molecular weight materials are pourable liquids, the higher molecular weight oligomers are quite viscous. Most of the commercially available oligomers used in radiation curable formulations are based on the acrylation of different chemical structures. The acrylation process imparts the unsaturation, or the C=C group, to the two ends of the oligomer. In essence, then, most oligomers can be viewed as difunctional entities. The photoinitiator is a critical component of the UV curing process. Photoinitiators may be described as chemicals that respond to UV light, typically in the 250 to 400 nanometer range of the electromagnetic spectrum, by generating a free radical capable of initiating rapid polymerization. As UV light energy is emitted, it's absorbed by the photoinitiator. The photoinitiator then fragments into reactive species called free radicals. These species react with the unsaturated compounds in the liquid formulation and cause them to polymerize. This reaction is almost instantaneous. Additives to inks and coating formulations can be defined as materials that may be desirable to improve the properties or performance of the formulation. First, surfactants, fillers, slip additives, and anti-foam agents are examples of additives that modify the performance or the chemical properties of the formulation to assist in the application process or enhance the properties of the coating prior to application. Second, the long-term appearance or durability of a UV-cured ink or coating may be enhanced through the use of additives such as UV absorbers, light stabilizers, and optical brighteners. A good understanding of the interaction of all formulation components within a formulation guides the selection and balance of these additives. The next few slides will summarize the various additives required by today's diverse applications for free radical UV systems. Besides the free radical chemistry discussed, there are other systems which also avail themselves to the use of UV-EB processing. Ultraviolet light sources are capable of activating a unique class of photoinitiators, which can, in turn, propagate a polymerization via an ionic rather than via a free radical mechanism. Because this is a fundamentally different chemical mechanism, different reactants, such as resins and reactive diluents, are required. This type of chemistry does not function with the type of double bonds, or unsaturation, found in the oligomers and monomers in free radical polymerization. Cationically, UV-cured coatings have become an important part of the overall UV cure market. However, the cationic market represents only about 3% of the overall radiation curing industry, with 70% being found in beverage can manufacturing. Cationic chemistry is less understood than the free radical-based systems, and formulating skills are rather limited. In addition, the availability of raw materials is confined, and are in the majority, based on epoxy resins. Whether a company formulates its own coatings or has a formulator supply the material, the first question to address is, what are the desired properties of the end product and the process parameters during manufacturing? The product properties determine the formulation, but the formulation used to achieve those properties affect the process parameters, such as the viscosity and cure speed. Thus, the balance between the properties and the process parameters must be kept in mind during the development of a formulation. The next 4 slides summarize the materials used in a formulation, and the general effect each has on the final properties.
Parts per 100 parts resin, or PHR, rather than a percentage measurement, is frequently used in chemistry. The difference between PHR and the percentage formulations can seem small but give large changes in the final product properties.